Okay, we have got this time area of a circle. So area of a circle is all about filling the inside of a shape. And within that inside of a shape, what we're going to do is effectively draw squares inside of it. And then every square that we've drawn is effectively like 1 centimeter squared or 1 meter squared through there. Okay, so that is what we are aiming to do. We don't need to physically draw them on, particularly seeing as when we get around the edges and stuff, it'll be a lot harder for us. What we want is a formula to be able to do this. So for a square, it has a particular formula. For a triangle, for trapeziums, for parallelograms, they all have their own formula for area. For the circle, that's no different. But what it does come back to is this beautiful pi. Okay, this time instead of pi times diameter, which is for circumference, we want pi multiplied by the radius squared. So the radius is half the way across to the center. So from the edge, our circumference of the circle, all the way to the center point, halfway across in a nice straight line. So if this was 6 meters, the first thing I would do is write area equals pi times the radius squared for a circle. And then underneath that, pi multiplied by 6 squared. If this was non-calculator, the next thing I would now write would be the answer to that, which is 6 multiplied by 6 is 36. So I've got 36 lots of pi. Okay, I'll just put a little arrow just to remember that we've done 6 multiplied by 6. At that point now, I can then put that into my calculator and then turn that into whatever I need it to be, like to decimal places, or again, if it only wants it as a terms of pi, I could leave it in terms of pi. What this gives me an answer of as an area is 113.09733, and then it goes on forever and ever and ever. What I'm going to do is stop at this point, and I'm going to do my area, and I'm going to do it to 1 decimal place. So it's either going to be 113.0 or 113.1. The next number after that is a 9, which means I need to round up. So my area is then 113.1 meters and then squared because we're dealing with area. So that's how you find the area of a circle when you've got a radius. It doesn't matter if this number is a whole number or a decimal. The process is always the same. Pi multiplied by the radius squared, and then you go through. Right, let's just go back and we'll have a look and see what we do once we get a diameter. So a diameter is all the way across the circle. So if I'm coming all the way across my circle, that now means that I've got a diameter, so I'm going to have to do something. So a diameter is made up of 2 radius, but r squared doesn't mean 2 multiplied by the radius. It means radius multiplied by radius. So if I've got, let's take 7 as my diameter. Let's stick to meters. My radius is going to be half of that. So I've got 3.5 and I've got 3.5. I only need to use one of them over here for my radius squared because the squaring is going to do the other bit for me. So I'm now going to write in pi multiplied by 3.5 squared. Because you've got a decimal, this is more likely to be coming up on a calculator paper. And that gives us an answer of 38.4845 and so on. In regards to having a pi sign, what you might find is on some calculators, you might have a fraction with the pi after it. So instead of having like 5 pi, you'd have a fraction and pi, but I just go to that decimal and then look to round it. So again, I'm going to do it to 1 decimal place. So I'm going to box around one number after the decimal point. So I've either got 38.4 or I've got 38.5. Because the 8 is the very next number, that means then that my area is going to be 38.5, and I'm in meters squared. So that is the area of a circle with a diameter. Okay. Other potentials that you might find is if you had a circle which was in half. So if you only needed to work out what half a circle was, let's get rid of the circle. Well, I should leave that actually. Let's say we only want half the circle. So we only want to know this area here. The chances are they'll give you a diameter because you've got this whole length across. So let's say that our diameter is 10 centimeters. I only want to know what this shaded area is, which is half of my circle, but I'm still going to go for pi multiplied by my radius squared because it's still area. Half of 10, because currently this is a diameter, I want a radius. So half of 10 is 5. So I've got pi multiplied by 5 squared, which gives me 5 multiplied by 5, which is 25 lots of pi. The next thing then I need to do is, because I only want half of that shape, I'm then going to take my 25 lots of pi, and then I'm just going to divide it by 2. Then that will give me my answer. So I've got 12.5 lots of pi. So I'm going to just go through pi multiplied by 25 and then divide it by 2 equals 39. And I'm just going to round it 39.3. And then centimeters squared. So that's my final answer once rounded. And I'm just looking at the area of that semicircle. Right, the next and final thing that you might get would be when they then start to combine it with other shapes. So if you had a circle, but you also had a square, let's see if I'll make that a bit bigger. Okay, this square, oh, how do you move it? Oh my days. Look at this, I'm a proper tech. What have I done? No idea. Right, let's get rid of this. Because clearly what I'm doing is not right. Let me just draw a square around it. Right, pen. So if we had a question where there was a square around the shape, let's just move that line up here. What it might ask you for is just the area of these shaded regions around the side. Okay, so when you've got that, you've got two shapes here. The first one you've got is the area of a square, but you also have the area of a circle. If we do the area of a square, subtract the area of a circle, that would then tell you what those shaded parts are worth around the outside, because it would just effectively just cut out the circle and then just leave you with those scraggy bits around the side. So if we put that into context, let's have a look at some numbers. So we want to find this scraggy bit around the side. So it's going to tell me that the area, sorry, not the area, the sides of my square are going to be 6 centimeters. So if I know a square's got all equal sides, that means then that my area for the square is going to be 6 multiplied by 6, which is equal to 36 centimeters squared. The next thing I need to do is work out the area of my circle. So from the side all the way across to the other side is 6 centimeters. So in terms of a circle, that is a diameter, which means I'm going to need to half that to get myself a radius. So half of 6 is then 3 centimeters. So for area of a circle, I've got pi multiplied by 3 squared, which gives me 9 lots of pi. I'm not going to change it into a decimal because I want to do my subtraction first. So now I'm going to do my area of my square, subtract 9 pi. Both of these things, even though I've got a pi sign, both of these things are in centimeters squared because we've used 3 centimeters, so we're all good. Right, so that gives us a final answer for those scraggy ends as 7.7 centimeters squared. That is as long as my calculator has done BidMaths, which I'm hoping it has. Let me try it on this badge. Right, so I've got 36 subtract 9 multiplied by pi. Yeah, perfect, 7.7. Okay, so there's the various different combinations that you've got. Obviously, any questions, just ask someone else.